Hello, I'm your host, Tyler DeWitt, and today we're going to be diving into the science of a most precious and powerful resource, water. Right here in America, we have geographical areas that are incredibly, wildly different, and so are the ways that water works in each of them. You've probably all seen pictures of rainforests such as this, the Amazon in South America. But I bet you didn't realize we have a rainforest right here in the United States. Today, we'll first travel to the lush, rain-soaked splendor of Washington State. Its magnificent Olympic Peninsula features tremendous rainforest trees, snow-capped mountains, some of them volcanoes, and rivers teeming with salmon. Next, we'll zoom over to the dry, hot Arizona desert and the scenic Verde River that winds through it. Unlike the Pacific Northwest, much of Arizona has a very dry climate that is known as arid or semi-arid. That means that water works in a completely different way here. In the dry Arizona desert, you might not have a drop of rain for months, and then boom, a flash flood will dump 7 inches of rain in one night. A lot of Arizona's land is desert, but that doesn't mean there's no life there. The desert supports unique plant life, such as types of prickly cactus, and the Verde River supplies water for migratory birds, beaver, fish, and of course, people. Each of these environments will explore how geography, water, and people work together. And we're going to see some amazing images of beautiful landscapes and rivers. We're so excited to be joined today by Kari Viggerstall, a senior scientist on the Nature Conservancy's Global Water Team. Let's watch this short clip to find out a little bit more about Kari.
I'm Kari Viggerstall, and I work for the Nature Conservancy as a freshwater scientist. My interest in nature comes from when I was a kid, and I was just like way crazy in terms of my energy, and my parents just like sent me outside and was like, you need to go outside and you need to get rid of your energy. So I started going for runs with my dad in the woods. It was a really important connection for us, and it also really helped calm me down and helped me get more focused in school and everything else I was doing. I studied environmental and civil engineering, both in an undergraduate, and then I did a master's in environmental and civil engineering, but I focused in water resources. I know that it can be a challenge sometimes as a woman becoming a scientist, but I was really lucky that I had a lot of support from my family. It was sort of like, yeah, you're gonna be a scientist. As I was doing my degree in college, I realized I really just was excited about water, and I could see how important water was to everything we do. I find science really exciting because to me it answers those questions like why and what's going on behind the scenes, just really why the world is the way it is. For me, I think that's just that curiosity. I think it's really exciting because we can solve questions around climate change and questions like how we're going to get to interstellar space. Science is the basis of all of that kind of stuff.
It's so great to have you with us today, Kari.
Hi Tyler, how's it going?
Great. So you're joining us from Seattle. Is it raining there today, Kari?
I am, yes. It was raining on the way to work this morning. I got pretty wet walking in today.
It's raining here too. We're at the Nature Conservancy World Headquarters in DC, and it was a very rainy day. So I know that you're a scientist, and I know that the type of scientist you are is called a hydrologist. Can you tell us a little bit about what a hydrologist is and what a hydrologist does?
Yeah, definitely. Great question, Tyler. So a hydrologist is a type of scientist who studies water. So we study water from the time that it falls from the sky as rain or snow, and we watch water as it moves across the landscape, as it runs into rivers and streams and lakes. We're also concerned with how the quality of the water is, so whether or not it's dirty or clean. And we do work on making sure that we're sharing the water between all the different uses. So for example, at the Nature Conservancy, one parts of my job here is to make sure that we can share the water between farmers and cities and other users who depend on the water for their livelihood.
Awesome. We'll look forward to learning more from Kari during this event. Now it's time to welcome our participating school, the F.E. Bellows Elementary School in Mamaroneck, New York. We're joined by Ms. Burstein's and Ms. Spedafino's 4th grade classes. It's great to have you with us. Okay. Let's start our trip and head to the Pacific Northwest, which is the home of a temperate rainforest. A temperate rainforest is a type of a woodland that has a mild climate with heavy rainfall. You can find these types of rainforests all over the world, as you can see in this map. But today, we'll be exploring the temperate rainforest of the Pacific Northwest. Here, The rainforest spans from Northern California all the way up to Alaska. Kari, you're in Seattle, not far from the Olympic Peninsula, which is Washington State's part of the Pacific Northwest temperate rainforest. Can you tell us more about what kinds of plants and animals we'd find living there?
Absolutely, Tyler. The Olympic Peninsula is a temperate rainforest filled with huge, tall trees. This includes the Douglas fir, the hemlock, the cedar, and the spruce. Now, these trees can grow over 150 feet tall and live to be hundreds of years old. So this tree that we're going to see here, the Quinault Lake red cedar, is the largest known tree of its kind. It's 174 feet tall. There are also lots of special animals that live in the rainforest of Washington State. Because the Olympic Peninsula is a peninsula, that means it's surrounded mostly by water and is pretty isolated, it has unique animals. So take the Olympic marmot, for instance. This is a cousin to the squirrel and is found only in Washington State on the Olympic Peninsula. They're about the size of a house cat.
They look so cute. Kari, have you ever come face to face with a marmot?
I have, Tyler. Yeah, when you're hiking Olympic Peninsula, you sometimes, if you're really lucky, get to see a marmot.
How do they feel about people?
They're a little bit shy, so you have to walk kind of quietly, and they might peek their head out, but they often pop right back in when they see you.
And are marmots dangerous in any way?
No, not at all. Not for people. They're pretty tiny, and like I said, they're pretty shy, so they usually run away.
That's awesome. So, Kari, we talked a little bit about the plants and animals. Can you tell us what's also interesting about the climate that we'd find in the Olympic Peninsula?
Yeah, sure, Tyler. So that is actually one of the coolest things about the Olympic Peninsula. And the temperate rainforest, which is on the peninsula, is actually how much rain we see every year. So on average, we can see from 140 to 167 inches, which is 12 to 14 feet of rain every year. Now, if you live in Seattle, where I am, you're probably going to get a little bit less. So we get about 36 or just over 36 inches of rain per year, mostly in drizzle or light mist.
But it sounds like you definitely don't want to leave home without a raincoat.
It's true. For most of the year, you definitely want to make sure you take your raincoat with you in case it's raining. But you know what? All the fresh water is super important. So just think about all the different ways we use water. We obviously need water to drink, so it keeps us hydrated and healthy. But we also cook and we clean and we wash with it. And we use it to grow food. And we play in it too. So think about how amazing it is to swim in fresh, clean water on a hot summer day. So water is crucial to so many things.
So what is it about the Pacific Northwest, and Washington in particular, that brings so much rain to the area?
Yeah, it's no accident, Tyler. So it's all due to the physical features of the land in this part of the country. So there are mountain ranges here that are really tall. Our tallest peak, Mount Rainier, is over 14,000 feet tall. That's about half as tall as Mount Everest, the world's tallest peak. And those mountains are pretty close to the Pacific Ocean. So some of the water from the huge ocean evaporates and it moves towards the land. And then it runs right into these tall mountain ranges. The winds force the warm, wet air upward, and as it rises, it cools, and the water starts to condense, and that causes rain. So by the time the air makes it over the mountains, it's rained out most of its water.
And so I should just point out that by condense, we mean that the water changes from a vapor or gas into the liquid raindrops that we feel when it rains. I bet you've seen this yourself. If you have a cold drink on a humid day, water drops can form on the outside of the glass. It looks like the glass is sweating, but what's happening is that water from the air cools down or condenses on the surface of the glass and turns into liquid water. That's what we call condensation, and that's what makes it rain.
That's right, Tyler. So let's take a look at a Google Earth image of Washington State. Now you'll see that behind the mountain ranges along the coast, there's this brown part over to the right. So the moisture from the ocean can't make it over the tall mountains, so all the land behind the mountains is much, much drier. It's not green and filled with plant life as it is along the coast. So we call this phenomenon the rain shadow effect. Washington State is amazing because it has both a rainforest and a semi-desert.
That's amazing, Kari. I never realized how much mountains could influence rain patterns. That if you have a big mountain range, you could have rainforest on one side of it and desert on the other. That's really interesting. You know what else is really interesting is water. You're totally right. It's a huge part of our everyday lives. And sometimes we might not even notice how much we depend on water every day when we can just go to the tap and always and instantly have fresh, clean water. Hey, let's ask our fourth graders in New York. Do you know where your drinking water comes from?
Hi, I'm Ilias. I live in Mamaroneck, and my water supply is obtained from the upstate Catskill and Delaware watersheds of the New York City water system.
Very nice. Now, how about you, Kari? Where does your water come from over there in Seattle?
Yeah, Tyler, our drinking water here in Seattle comes from two different rivers, the Cedar and the Tolt River watersheds. These two rivers flow towards the ocean from the mountains and bring us our drinking water here in Seattle along the way. So one of the students mentioned the word watershed. That's great. That's a really important term, and let's talk about what that is for a minute. So everyone in the world lives in a watershed. A watershed is an area of land that drains to a common body of water, like a river, lake, or ocean. The boundary of the watershed is like a line that connects the highest points in the land area. Water flows down from those high points through creeks and streams whenever it rains or snows. The shape of the land affects where the water goes. So hills, mountains, canyons, and any other physical features of the land affect where the water will drain to in a watershed. So water flows down to the lowest points, it can carry things along with it. So if it runs into a city, a farm, a park, a school, or a forest, anything there like dirt, fertilizers, litter, or anything else can wash along with the water into a stream, lake, or ocean. Now the cool thing about a watershed is that anything that happens within a watershed can impact the water there. So let's look at a group of tall trees in a forest, for example. So when it rains in a forest, the leaves of the trees help to break up the raindrops as they fall, so that by the time they make it to the ground, those raindrops are smaller and land more gently. Now this gives the water a chance to soak into the soil.
So, Kari, the trees help slow the water down, but what if those trees get cut down?
Yeah, that's a great question, Tyler. So if the trees aren't there, you won't have the leaves to slow down those drops, and the drops will hit the ground much harder, and it will be harder for those drops to soak down into the soil. So now instead of soaking into the soil, they're actually going to run off the surface of the land, and they're going to run off a lot faster, and they're going to pick up all that stuff I talked about, so the dirt and the pollutants, maybe trash and other things that are sitting on the ground, and that will all rush with the water and swept into the river, lake, or ocean by that water. And so this impacts the quality of the water in that river, lake, or ocean.
So, Kari, tell me about cities like Seattle. They don't tend to have big groups of trees in the first place. So are they in a watershed? And I'd also ask, what happens to rainwater when it moves through a city like Seattle?
So first of all, yes, Seattle is in a watershed. So we all live in some watershed. And we're going to share now a quick demonstration of what happens in an urban watershed like Seattle versus a more natural watershed. So we're going to check that out in a video we put together.
Awesome. So before we watch this video clip, you need to know a couple of terms. The first is impervious. An impervious surface is any surface that can't soak up water. So any type of concrete, building, paved roadways, parking lots, you get the idea. You can imagine how many impervious surfaces there are in a city. Now, the second term is precipitation. Precipitation is water in the form of rain, sleet, snow, or ice. The third term is infiltrate. Infiltrate means to go inside something, like how water infiltrates dirt when it soaks into the ground. So you could say that water cannot infiltrate an impervious surface. So now let's watch this video clip where Kari conducts a simple experiment that you and your teacher can even replicate in your classroom.
So I'm going to take some of this concrete here, and we can use any kind of impervious surface like concrete or rocks or anything you'd find in an urban area where things are paved and water can't infiltrate in. So I'm just going to fill this up with lots of different pieces here. This represents our impervious area, and it's made up of concrete or rocks, the kinds of things you'd find in an urban area. Okay, now we're going to work on in the natural area, and we're going to start off. We've got our ingredients here: the soil, sand, we've got leaves and moss. So let's start with a little piece of moss down here, and then let's put in some soil. These are the kind of things that we would find out in natural areas. And a little bit of sand. All right, so maybe we'll add a little bit more moss and some leaves. We've got our two different watershed areas. We've got our impervious area and our natural area. And so we're ready to put those aside and work on creating our rainwater. So we're going to have our water just as if it's raining on these surfaces. We also have the oil, and we're going to use some dirt. Okay, so we're adding soil to our jars, and this soil represents all the different kinds of pollutants that might be added to the ground, so like fertilizer and pesticides that can be picked up by rainwater. Now we're going to add some water to our jars. So this water represents the precipitation that's falling on our impervious and natural areas. So I'm going to fill this about 3/4 of the way up. Leave some room for our oil. So this oil represents the oil from cars that's on the streets and driveways. It also can represent other types of pollutants and chemicals that are sitting on the landscape and it's picked up by the rain. Let's mix up all that rainwater and dirt and oil. So now we've got 2 mason jars of pretty dirty water, and we're going to see what happens when we pour this water into the 2 different landscape areas, the impervious and the natural areas. Okay, now let's get our soda bottles ready, and we're going to see what happens when we pour this water into here. Oh, a little tight there. And what I'm going to do is pour them at the same time, and we're going to watch what happens as the dirty water moves through the different columns. I'm going to pour this into both of these soda bottles. As you watch the water move through, you can definitely see a big difference between the impervious side and the natural area side. This is a good example of how water moves through an area when it's impervious versus natural. In an impervious area, the water moves across that area really quickly. Okay, now that a little bit of time has gone by, let's see what's happened here in each of our soda bottles. So as you can see, the one with the impervious area here is pretty dirty, and the one that in here in the with the natural area is a lot clearer. I mean, it's not crystal clear, but it's much cleaner. You can see the big difference between the 2 different soda bottles. When we look at the levels of water, all of the water that fell on here, most of it made it through. It hit the pieces of concrete and rushed right through to the bottom of the soda bottle. Whereas on this side, there's still water sitting in those natural areas, in the moss and the dirt and the sand, and it's continuing to drip through pretty slowly.
That's amazing, Kari. When we do experiments in science, we kind of want to figure out what we concluded, what the main points were that the experiment showed. So what would you say the conclusions of this experiment are?
Yeah, Tyler, I think that the conclusions of this experiment showed us that when rainwater runs off a landscape, it acts differently whether or not it's paved or impervious versus whether it has more natural areas. So we saw that those natural areas could actually clean the water as it runs off, and that water runs off a lot more quickly in the urban areas.
That's really fascinating, and it's so cool to be able to see a demonstration of it in the lab. I mean, like, we could really tell the difference between that water that's running through the impervious area and the water that's running through that more natural area. That was awesome. I'll bet that our 4th graders have some questions for you after they've watched that experiment. Let's find out what they're wondering about.
Hi, I'm Jillian, and my family has a garden in our backyard. Does that affect the watershed?
Yeah, a garden is a great way to help clean the stormwater as it runs off the landscape. So especially in an urban area where we have a lot of impervious area, by creating a garden, you can create spaces where the water can be infiltrated and cleaned as it runs off the landscape. So that's great. I'm glad you guys have built a garden in your backyard.
All right, let's get another question.
In your experiment, how does the dirt and moss act as a system?
That is also a great question. So as you can see, as we poured the water in there, some of the water kind of got stuck in that area where the dirt and moss were. So there's lots of little spaces in between the dirt and the moss where water can flow through, but some of that dirty water or the pollutants such as the oil and some of the other dirt got stuck in the dirt and the moss. So that's why on the other side of that stuff that was in the bottle, the water was cleaner than when we looked at the other side where we didn't have the dirt and moss to capture that dirt and oil.
That's awesome. So let's see if we have any questions from our live viewers. So here's one that just came in. This is from Deb Hibden, and she asks, why is rain so important?
That is a great question. So, yeah, rain, as we talked about since the beginning of this session, rain is really, really important because that's where all of our water comes from rain and snow that come from the sky and deliver our water every year. So it's really important for us, to be able to get that water source every year so that we can have that water for all the things that we need it for. So even though sometimes we step outside and we're kind of grumpy because it's raining, actually, we should be really thankful that it's raining because that water is really important for all the things that we do.
Now we have another question here, and this is about you, Kari. This is from a viewer,
Okay.
Katrina Maxwell, and she wants to know, Kari, what made you decide to study water?
Yeah, that's a great question. So I just, it was sort of from just looking around and realizing how important water is. I just started thinking about what was important in terms of what people needed and for people's health and for all the things that we do. And I realized that water could be integrated into all the different types of topics we could study. So even law and sociology and history and all those different subjects, water is a part of all those subjects. So to me, that was really, really fascinating. And that's why I decided to focus on water when I was doing my studies.
That's so cool. It sounds like an awesome area to focus on. Now, let's travel to another part of the country with a very different climate. We're going to go to the Arizona desert. So there are some words that we can use to describe areas that have different climates and that are home to different types of living things. We can call these areas ecosystems or biomes. So the Pacific Northwest, with its temperate, rainy climate, is one type of ecosystem or biome. Now, the dry Arizona desert would be another type of ecosystem or biome.
That's right, Tyler. And the deserts are supposed to be dry, right? But a desert can also be dry and hot, or it actually can be dry and cold. So Arizona has both of these types of deserts. There's the Great Basin Desert, for example, and it's a cold or temperate desert because it lies within the Colorado Plateau, which is a massive area of land in Arizona, New Mexico, Colorado, and Utah that is at a high elevation. And this causes the desert of northern Arizona to be dry and cold. It even snows here in the winter. We also find the famous Grand Canyon and Colorado River in the Great Basin Desert of northern Arizona.
So Kari, you talked about a cold desert, but there's another kind of desert in Arizona. The Sonoran Desert in southern Arizona is one of our country's hottest deserts, and it stays warm there all year long because that desert lies at a much lower elevation than the desert that you talked about in northern Arizona. Now, it's dry in the Sonoran Desert too, but because that area has 2 rainy seasons every year, some unique plants have been able to adapt and thrive there. Check out the saguaro cactus. It even has flowers and fruit and relies on birds, bees, and even bats to pollinate it. Kari, what's one really key difference between this desert biome and the Pacific Northwest biome?
Tyler, water is a huge difference here. So on the one hand, we have a biome with lots and lots of water. And on the other hand, we have a biome that lacks water. And what's really cool is that the plants, animals, and people that live in these 2 biomes have adapted to these 2 different environments where we have, depending on how much or how little water they have.
Totally. So let's do this. Let's compare and contrast the saguaro cactus of the Sonoran Desert in Arizona to the Douglas fir, which is a common tree in the Pacific Northwest. Here's a photo of them side by side. First, here's how they're similar. They can both be very tall. They can both live a really long time. The saguaro lives more than 150 years, and the Douglas fir can live many hundreds of years, but that's really where the similarities end. These 2 plants have adapted to live in the conditions of their habitats, which, as we've explored, are really different. Kari, tell us about this.
Sure, Tyler. Saguaro cactus in particular has adapted some really cool features to be able to live in the hot, dry desert of southern Arizona. So if you notice, they have spines on the cactus, and these spines help the cactus to conserve water. So for one, it helps deter animals from eating the cactus so they don't get poked. And 2, because the spines prevent the water from evaporating from the cactus. So the cactus is kind of like a camel, which is another desert creature, because it's designed to go for a really long time without water. So like a camel, the saguaro can store lots of water. It can soak it up when it rains, hold on to it for long periods of time when things are really dry. Saguaro, as you mentioned, can also live for a really long time. In fact, they have no arms for the first 100 or so years of their lives. They don't even grow their first arm until they're 100 or older. Think how ancient this guy must be.
That's really amazing, Kari. So I want to show you something cool here. We're now going to take a look inside a cactus so you can see what a magnificent water storage unit it is. So take a look at what I got here. This is a barrel cactus. It's a type of cactus you can find in many garden stores, but it stores water just like the larger saguaro cactus. So what I'm going to do is I'm going to take my knife here and I'm going to slice the cactus in half so that we can take a look at it. All right, here we go. And there it is. There is the inside of a cactus. You can see that this area here looks kind of damp and spongy. And when I press down on it, it releases water, just like if you squeeze a wet sponge. This is kind of like a cucumber. So this area here in the middle of the cactus serves as a reservoir so that it can soak up water. Now, you'll see that the edge of this cactus has a zigzag or sort of accordion shape. And that's so that the cactus can soak up water and expand to store it. And then as the cactus uses that water, it can slowly shrink down. Now, if we took a tree like the Douglas fir and we cut it sort of sideways here, the same way we cut this cactus, all we'd find is a whole bunch of dry wood. The Douglas fir just doesn't need to store water in it the way this cactus does. So this is a really interesting way that the cactus has evolved to store water. Let's talk about the people of this region who've adapted to the lack of water. They live here by the millions in cities like Phoenix, which is Arizona's largest city, where the average rainfall is only 7 inches per year. Kari, can you tell us a little bit more about how people deal with such scarcity of water?
Absolutely, Tyler. So just like the saguaro cactus, people have to do things differently too because water is scarce. So for example, let's look at the wild and scenic Verde River. This river provides drinking water for the 3.5 million people in the Phoenix metro area, as well as provides homes for bobcats, beavers, mountain lions, and bald eagles. What's different about the Verde River from the watersheds we looked at in the Pacific Northwest is that the Verde is mainly fed by groundwater. Now, groundwater is the water that's found deep underground. If you have a well at home you get your drinking water from, this is groundwater. This is really different than all the surface water we saw in the Pacific Northwest. Surface water is the water that's held in lakes, rivers, or oceans. This water is all at the surface. In the Pacific Northwest, because there's so much rain, the lakes and rivers get their water from the runoff of rainwater. The Verde in Arizona gets much of its water from groundwater that moves up to the surface and then moves along through the Verde, just because there isn't that much rain to charge it.
That's amazing, Kari. Let's take a question from the 4th graders who are probably curious about a lot of things we've talked about.
If there is not a lot of water, how do all the people who get their drinking water from the Verde make sure there is enough water for themselves and all the plants and animals that also need it?
That is a great question, and it's a huge challenge that people and organizations like the Nature Conservancy are working on. So there are things we can do to make sure there's enough water for all of us, for people and for nature. You can change your habits to conserve water, so like not washing your car or turning off the water when you're brushing your teeth, taking shorter showers. So these are things that are good to do no matter where you live. And more, especially in places that are dry, like in Arizona, farmers are doing things a bit differently to conserve water. And this is really important because it takes a lot of water to grow food. So for example, farmers are switching from spray irrigation to now using drip irrigation. And drip irrigation conserves water and allows farmers to do their part in conserving this scarce resource. So for those who live near the Verde, it's really important to share the water. The water is needed for growing the food on the farms, for drinking, for cleaning in the cities, and even recreationally for kayakers on the river. So we need water for so many different things.
So we just learned about groundwater and how the things that people do affect the supply of water. But Kari, is there no surface water at all? What happens to the water that does come in the form of rain?
Yeah, good question, Tyler. So surface water is scarce, but it does rain in the desert. And what happens to that rainwater desert is, again, wildly different than what happens to the rainwater in the Pacific Northwest. So there we learned how the ground is able to soak up and store the water. In the desert, the ground and soil is very dry. So when it rains, that ground is really hard and the water just runs right off the surface and it doesn't soak up into the soil. So you end up seeing a phenomenon called flash flooding. Now, let's watch this video of a flash flood in action. So a flash flood occurs when a lot of rain comes down into the desert in a short period of time. The ground can't soak up all that sudden blast of water, so it runs off into creeks, streams, and rivers. Often these creeks and streams are completely dry, and then all of a sudden, there's a lot of water moving through them. So as you can see, the water is there and gone really quickly. It's moving so quickly that people and wildlife don't have much of a chance to make the best use of that rainwater. So it moves across the land and into rivers quickly, and then it's gone. The creeks and streams are dry again. So this is why groundwater and rivers like the Verde are so important in places like Arizona.
I can see that. Now let's get a couple more questions from our participating classroom.
Hi, my name is Jacob. My question is, what dangers do flash floods cause along the Verde River?
Yeah, that's a great question. So as you can imagine, a flash flood could be dangerous. If you didn't know that it was coming and that, for example, you were hanging out by the river in the river, it could be dangerous. But often, hopefully, we have a sense of whether or not it's going to rain and rain hard so that we can have some kind of warning before the flash floods happen and that people can stay away from the river and make sure that they don't get hurt. But that's a really good question because you can imagine all that water coming at once can cause some damage.
All right, let's get another question.
Hi, my name is Russell, and how fast can the water in a flash flood travel?
Great question. So this can differ based on how much rain is coming and the amount of time that it comes in, but a lot of flash floods, sort of defining a flash flood is about 10 feet per second. So that water is moving across the landscape moving at 10 feet in 1 second. So you imagine that is pretty fast.
So it's almost time to wrap up. Here's where we went today. We visited the Pacific Northwest biome and saw massive trees of the temperate rainforest and rushing rivers. Then we journeyed to Arizona, where we learned how life thrives in the desert even when water is scarce, and we experienced the ferocity of a flash flood. We've all seen just how intricately nature is connected in all ways. The land affects the water affects the land and the people affect the water and the land. Change one thing and everything else changes. That's why it's so important to take care of our water supply and ensure that we all have enough clean water for the people, plants, and animals that depend on it. There are a number of things that you can do to make sure we all have good, clean water. First, the easiest thing you can do is go home and tell your parents, friends, or family what you've learned today. I bet there's at least one thing here that you learned that your family and friends don't know. So share it with them. They'll probably think it's cool. Second, you can help by following any of the great suggestions Kari made, like taking short showers or turning off the water when you brush your teeth. If you live somewhere like the Pacific Northwest where water is abundant, build a rain garden to help slow and filter the rainwater so it doesn't end up like the murky water in Kari's demonstration. And finally, recycle. PepsiCo helps support the work of the Nature Conservancy on the Verde River, and they have the Recycle Rally program that helps schools like yours compete in recycling challenges. The more we recycle, the more money PepsiCo will donate to protect our water sources. Now, on behalf of the Nature Conservancy, I want to thank everyone who joined us today. A big special thanks to our expert scientist, Kari Viggerstol. Thank you so much for joining us.
Thank you. It's been great.
It was a pleasure. And a big thank you to Ms. Burstein's and Ms. Spedafino's enthusiastic 4th grade students at F.E. Bellows Elementary School. Thanks so much. Now, don't forget to tune in on May 19th at 12 p.m. Eastern for our next live virtual field trip. Bring your scuba gear because this time we're going to the ocean. We'll see you later, everyone.